Well, we often start with some video just to get us in the mood. So let's do the same today. See if the sound works.
Das hier ist mein Sektor. Das hier ist das wichtigste Gerät des Küstenwächters. Das Gerät.
Das hier ist mein Sektor.
Das hier ist das wichtigste Gerät des Küstenwächters. Das Gerät.
Überlebensradar.
Mayday, mayday. Hello, can you hear us? Can you hear us? Can you... Okay, over, mayday. We are sinking. We are sinking.
Hello?
Over. We are
This
sinking.
is the
We
German
are
Coast
sinking.
Guard.
We are sinking. We're
This
sinking.
is the German Coast
What
Guard.
are you
We're
Thinking
sinking.
about?
We're sinking.
What are you thinking about?
Because one of the assignments in this is to make a little video within a group, and I guess it's not playing through here. Why is it not playing? It's not very important to hear the sounds on all these because I'll do the talking today, but you heard that. That's perhaps the only one that you need to hear the sounds for. So the last couple of years, so I record these classes, screen captures, and then load them online. And the last couple of years, I guess the first one is never taken because we're using Canvas the first time of COVID, and not that. And sound. Fine, don't care. I'm not going to worry about it. Do something else. Why not?
On January 15th, 2022, the Hunga Tonga Hunga Ha'apai volcano
On January
exploded in the
15,
nation of Tonga, and
2022,
what
the
was the
Hunga
largest
Tonga
volcanic
Hunga
eruption
Ha'apai
of the
volcano
21st
exploded
century.
in the nation
Don't
of
need
Tonga,
that.
and what
You
was the
know all
largest
about this,
volcanic
right,
eruption
from,
of the 21st century.
January in the Pacific Ocean, north of New Zealand, east of Australia. The biggest eruption in perhaps 100 years, but happened in a very remote part of the Pacific Ocean, and spawned a tsunami. And so this class is all about fluid mechanics, and so fluid mechanics, of course, is all around us, and we'll talk about that today. And so this is just a preamble before we get going. But fluid mechanics, if you have a volcano under the ocean and it blows up, then it creates some waves. It puts a lot of ash into the atmosphere. It creates a disturbance in the atmosphere. And what was interesting about this particular event is that the tsunami, they travel quite quickly. Maybe they travel at a few hundred miles an hour across an ocean basin. And the acoustic wave, the sound, travels at perhaps twice that speed, 600 miles an hour. And so there are infrasound sites around the world that measure sounds, mainly for nuclear testing, to be able to find out whether someone's doing some underground explosions, because they will pick up the sound from that, even if they're thousands of kilometers away on the other side of the globe, because it transits the globe. And of course, tsunami will follow, just like ripples on a lake, they're following exactly the same process. And so this particular eruption was interesting because the big explosion that pushed stuff up to, I don't know, 60, 70,000 feet, twice as high as you fly, made this big enough disturbance in the atmosphere. First of all, that the sound traveled all around the world, but also that the waves in the atmosphere that were created kind of reinforced the water waves in the tsunami and drove it, like driving something in resonance. And so the tsunami was much bigger than you'd have expected just from the splash of the explosion that occurred undersea. And so it's an interesting event for that. And so a dramatic event. Of course, the most stark exposition of that was last night when I was lying in bed at probably 3 o'clock in the morning, seeing a flash of lightning, and then measuring 6 seconds later when the thunder came in. And of course, the wave speed, acoustic speed in air is something like 600 miles an hour, so you can do the calculation that in 6 seconds it travels a mile. So you know the lightning struck something a mile away from where you were. 12 seconds, it'd be double that as well. So all part of what we'll talk about in this class. So Hunga Tonga, and so we won't get going with real stuff until people start arriving at 8, but this is just my little, oh, that's interesting zone. So you can see it exactly here. I've turned the sound off because it gets confusing, but this is exactly where it is. You can see the location just north of New Zealand, and this is just a model which would be backed up, of course, with tidal gauges around the world. When it arrives on the west coast of the US, you'd be able to pick it up on a tide gauge in Portland or San Francisco. And you can work out how quickly it arrives. So these waves will arrive twice as slowly as the infrasound wave because it's going at 300 miles an hour, surprising speed actually. As it crosses the ocean, of course, it's very small, maybe only a few centimeters tall, but when it runs up onto land, it's potentially much larger because the depth of water gets shallower, the wave gets higher, and it kind of overruns itself because of the drag on the bottom, and it ends up being a couple of meters, I think a few meters in Tonga, which was the closest inhabited island just to the north of it. So we'll talk about some things like that in this class as we go on. Don't need to worry about it now. The other thing, I guess, is quite spectacular. Oh, this is it, actually.
So, check that out, man. That's the volcano eruption. That's the clouds. Check all of that out.
I guess one of these is running in the background, which I don't want it to do.
The sound of the eruption was heard in many parts of the world, as far away as the US.
The sound of the eruption was heard
On
in
Saturday,
many parts
January
of the world,
15th,
as
the
far
underwater
away as the
volcano
US.
at Tonga erupted,
On
about
Saturday,
65
January
kilometers
15th,
north of
hear
the
the sound.
capital,
underwater volcano at
Nuku'alofa,
Tonga erupted,
triggering a
about
tsunami
65
that flooded.
kilometers north of the capital, Nuku'alofa, triggering a tsunami
Yeah,
that
okay.
flooded.
There you go. This is way before your time. If I got my math right, so you're probably rising juniors, and so that means you will be 21 this year. Risen juniors, I guess. And I've turned the sound off. So I guess you're born in 2002, right? On average? Is that right? Yes? Yeah. No response, please. Huh? 2001, yeah. Order of magnitude. We work in order of magnitudes in this class. That's certainly within that. And so one of your assignments is to make a presentation in a group of some interesting fluid mechanics phenomenon with a group of students we'll choose with you. I use the Poseidon Adventure. This is a movie which was probably the 70s or 80s, I don't remember exactly when, but was a boat that got caught up in a tsunami. And of course, tsunamis, as you're in the middle of the ocean, are a few centimeters tall. They're not a wall of water coming towards you. They only get that way close to the shore. And so one interesting topic might be, for instance, how do you, as a person, figure out whether what's happening here is when we see this boat being struck by the tsunami, which is just about to happen. The guy looks like Al Gore. Is that a real boat or is that a model boat? Probably a model. Yeah, just out of humanity's sake, but it's a model, right? So how do you know it's a model? And so one reason that you know it's a model is that the drops of water are much too big. You know the size of a raindrop. Can a raindrop get much larger than a raindrop? Turns out that it can't because of surface tension. You can't get a raindrop a meter in diameter because the surface tension isn't big enough for it to hold in place. And so my guess is that there are two cues that you do to see that that's a model. One is that the drops are huge compared to the ship. You can compare them with it. And also your eye scales the velocity at which they're moving. So something that's moving due to gravity, accelerating due to gravity, if you see it, it always travels at the same acceleration. So if you see it the background of a model, then it's still traveling with the same acceleration it would be on a full-size ship. So it's moving much faster relative to the model because of the background that is scaling it. And so those are two keys that allow you to I think, suggest that that's a model. So And you'll see that in some of the material for this class, there's a little example that's given exactly with that. So anyway. So I'm just entertaining myself and hopefully entertaining you. Okay. Hopefully a thing of the past. For the first, so for the last 2 years, I guess we've been in class. 2 years ago, we had social distancing. We were sitting in every fourth seat. The intermediate seats were closed off and the intermediate roads were closed off. Last year, we had a brief spate in the summer with no masks, and then we came back in the fall, and all of a sudden we're wearing masks for the full semester. I guess you were on campus both of those times. In fact, I suppose you started your university careers on the first full year of COVID. But fluid mechanics is also the mechanics of why you use masks. Fluid mechanics is how air goes in the interstices of a mask. It filters out saliva, the mist in your coughs, and of course you can do calculations to figure out exactly what the size of the mask pores should be, because it's a trade-off, because you'd like to be able to breathe, so air has to get through them, but you'd like not to spew your sickness over people. And so there's lots of interesting things that can be done. This is called Schlieren imaging, where you have a backlit scene that you can actually see this the turbulence of the air as it comes out of someone's breath, to be able to evaluate these things. And the other thing that was going on, I don't recall exactly when this was. That's the Poseidon Adventure, still running. Maybe I've lost it. I don't know where it is. So I don't see it. Come on in. Yeah, maybe I discarded it. The other thing that was going on at this time of year, maybe 2 years ago, was this huge Beirut blast where 27 tons of fertilizer blew up in Beirut harbor and just eviscerated the city, along, of course, with wildfires which are going on everywhere. Welcome. Grab a syllabus at the back if you want it. There's some here. You don't need it, absolutely, but it will test how good your eyes are. We'll go through things as we get through this. Wow, right on time. Good God. Was there someone at the gate not letting you in till 8 o'clock? All right, so welcome. Hopefully you're here for this class, EME 303. Once everyone kind of settles down, we'll get rolling. Today is just an introductory day. We'll talk about some stuff on the syllabus. We'll talk about class conduct. We'll talk about the fact that most of this stuff is served to you online and is available to you if you wish, but also will be in class at the same time. So grab your things and we'll get going. All right, I'm going to close that and reopen it just with Canvas. I presume you can see, and it's not too bright that it's a pain. So, welcome to 303. My name is Derek Ellsworth. I'm the instructor. I'm your guide through fluid mechanics for the semester. As I mentioned, we'll just talk about class conduct. The two websites you need to use. One of them is Canvas, of course, which you will be way used to using. And Canvas has everything on it that you will need. I'm just finding out I don't use Canvas so much, but I guess I could make it actually larger. I don't see Syllabus. Is that at home? Oh, there's Syllabus, yeah, okay. So on Canvas, there are a couple of things. One is the course syllabus, which Some of you have, if you've grabbed a paper copy, and you'll see it there. And we'll talk about that today. So Canvas is the one important resource where most things will be served. The other one is what I call a course resources page. And so this is my own personal page that has all the material on it. It even has the Poseidon Adventure, which we just watched on YouTube. And it has most of the things on this course resources page, including, as you can see, material from the last decade. In 2012, this class was put in the chemistry building right next door. I used to do everything on a board. It wasn't very convenient, so I started doing screen captures with written components and then posting it on YouTube afterwards. So these individual links, this would be the second class in 2021, just the screen capture. You'll see this stuff on Wednesday if you're still here. You still choose to join us, that is. And as you'll see here, we typically start the class with a little bit of video, a bit of fun to make some points that we might make, and then we divert and get serious by looking at things. So it's just a way of me being able to write on a board, not with my back to you, with my front face to you, and to be able to do the things we do in this class. So as I say, there are two relevant websites, this course resources page and Canvas. And so today, I guess I might just go through the syllabus. I tend to use this tool here, Notability, because I can write on it. So this is the syllabus that you might have downloaded. So today we'll just talk about two things. This course resources page, you can always find it. You can search on my name in Google. I guess being born in 2001 or 2002, Google has been with you for your full lives. It's good to have a moderately unique name. There is another guy by my name who's a pastor in Nova Scotia, and there is a guy who's a coal merchant in Yorkshire in the UK. Of course, you never search on your own names to see what's out there, do you? Of course, you wouldn't be that narcissistic. And so you can find me on there, or you can just go here, directs you directly to my Penn State page, and of course Canvas is the other component. So the class is this. So let's see if I can get myself in order. So this is how we do things. So we don't want that. So this is where we are now. Monday, Wednesday, Friday, 8 till 8:50. You know where you are if you're here. It's kind of a blended class in that some of the stuff is served to you online. We'll get to that in due course. The text is Munson. There's a copy in the bookstore. I think I saw it cost $120. They're used copies. It's expensive. You may wish to get it. I think if you're an aspiring engineer in the fields that you're working in, you might want to have a textbook on fluid mechanics. It's certainly a foundational science for the things that you'll do. All of the majors that are represented here, most of the class would be people in energy and mineral engineering department. So that would be petroleum engineers, mining engineers, environmental systems engineers, and energy engineers. And so fluid mechanics touches all of those in a very big way. You can also get the book online or rent it. I'm sure you're used to doing that as well. The easiest thing to do is to go to this site and search on Munson. There's a Munson 8th edition and the Munson 9th edition. I think they're the same price. It doesn't really matter which. We don't physically use the book in this class, but you might want a book on fluid mechanics as a reference text. I think it's just useful to you. And don't sell it if you buy it. It's the thing that you should take to your job if you're going to stay in this area. My name is Derek Ellsworth. I tell people we can be on first name terms, but very few people take me up on that. I presume to call you by your first names if I get to know you, and so I don't mind it being the other way. Usually it's, for you, you've got so many professors floating around that it's either you or hey professor, which is fine too, rather than learning a name. For this class we have an undergraduate TA, Jacob McInanty, I guess is the pronunciation. He's a student who took it last year and got an A in the class. And he'll set up office hours, 10 hours a week in 111 Hosler. And we also have grad student TAs who you can fall back on as needed. Shin, who's the coordinating TA, and Jia, who's kind of a backup TA. The 2 course resources pages, this is DerekEllsworth.com, this one here. Just DerekEllsworth.com just automatically links to this because I don't have any life on my own outside the university. And of course, Canvas, you know. The class has prerequisites. The prerequisites are these. I'm not sure what Penn State is doing about enforcing prerequisites. Personally, I don't care about prerequisites. Everything for this class, as you've kind of seen, is online. And so if there's someone who wants to take this class and who gets disenrolled by not having the prerequisites, as they may do, then I'm okay to sign off on the form that allows you to take it without the prerequisites, under the proviso that you have to be comfortable with the material and you're not going to be kind of a super burden on the TAs because you want them to be your personal tutors. But if you don't have the prerequisites and you think that you ultimately get disenrolled from it, which I think is the policy kind of at Penn State to do that, then you can apply to be reinstated. And I will do that, just as a matter of course. You just have to do the paperwork. The paperwork I'll sign off on. I'll say that all the material's online and that you've checked it. And I'll say that also that you've agreed that you're comfortable with the material, just as if you've taken the prerequisites. And you can find out whether that's the case for you or not. The grading is as there. It's a relatively straightforward course. I'll go through the individual components, but you can see it comprises assignments, it comprises a group project, it comprises midterms and a final, final being less than the midterms, and some extra credit quizzes for the times when we're taking the tests. The tests are physically in class time within the semester. And so if your eyes are good and you can read what's exactly on this, the red circles are the individual midterms. The blue circles are when I will post a review session online that points you towards the topical areas that are in those midterms. And the midterms are on the Monday, Wednesday, and Friday class we usually open them up at 7:55, but they're nominally 8 o'clock to 8:30, but they run 7:55 to 8:31. They're done online. They are Canvas supplied numerical answers typically, not multiple choice, with a plus or minus 10% bound on the answers. It's not an extra credit exams. And so we'll talk about the exams when we get to it. So you need to be available for these weeks and these classes. Most of the stuff in this class, ultimately, I'll turn up to class, I'll record it, I'll post it online, but whether you choose to come to class is absolutely up to you. There's no positive or negative in doing one or the other. It's just based on your own personal preferences. So back to the assignments. So the weekly assignments are served to you on Canvas. The reason I say that the book or not is absolutely your decision, because the assignments are from the 7th edition of Munson and they're supplied to you on Canvas. So the questions that you have to do for these assignments, which are noted here, are from the 7th edition. And they're available to you on Canvas. Don't do the ones in the book if you have the book. And so that's a facility to you. So if you want to buy the book, great. If you don't, fine too. But that's where they are. And I'll show you how to get them off Canvas later. You'll do a group presentation. We'll set you up in groups of about 5. It'll be around Thanksgiving. We used to do it live and have everyone present in front of the class in the last week before Thanksgiving. But now the students record them. It's a 5-minute presentation. It could be 1 slide, it could be 5 slides. It's to show that you know something about some interesting, enigmatic, mysterious topic in fluid mechanics, and to be able to entertain, just not a mundane topic. Everyone will choose, why do you twist a football when you throw it? Why does a a rifle barrel have rifling in it, and to spin the bullet, etc. But there are much more interesting ones, and we have some examples from past classes. The midterms, there are 3 weeks of midterms, each worth 20%. Each of the days is worth 6.67. And the final is in the last week of classes. And for your protection, you're protected against doing anything that provides more than 10% to a final grade. So that's why the final is slightly less weighted, half weighted than the midterms. And it's actually kind of appropriate because even though the final is quote unquote comprehensive, it never is. It's just the last couple of weeks of the class in terms of what we do. When you are in class when you're taking the exams in those weeks, then we're not having class. So it doesn't mean that you get off class because we have material that we need to cover. And so you'll be asked to do the classes on those days, within the weeks where you're doing the exams. So at some time between the Monday and when it closes at midnight on Friday, you'll do class 6.1, and you'll submit a 10-question quiz just to show that you've seen it. So that's how we'll do that in those weeks. So this designation means online and asynchronous. I think it's noted at the bottom. And so these are just in classes. I imagine, so the extra credit for the 4 weeks is this week here, this week here, this week here, and for this week here. Actually, it's a gift because this isn't a real week. It's actually only 3 weeks. It's this week, and this week, because this is an open week with no classes. And so also I'll get you on Labor Day, which is the 5th, to do a quiz here because we won't have class. But there is so this will be 3.1. So all these individual classes are numbered by the week and the 1, 2, 3 for the Monday, Wednesday, Friday. So I think it's pretty straightforward. I know it might be like drinking out of a fire hose. I don't mean it to be that way, but I'm sure you guys have the capacity to take all this in. Yeah, so the 4% is for 3 weeks, 0.3, a third each for each of those ones each of 3 weeks, and an extra if there end up being more classes that are online for whatever reason, then this number will boost. That's always useful. The other thing is that the midterms and the finals are also graded out of 110%. So each of the finals, although it's 100, you can score 110%, but it's only 100% final. So you get 1.1 times your score on your final. So that means that 60%, 70% from both of these means that 70% is really 77%, right, for the 10%. And so this final score, including the extra credit for the 4%, is actually 104 plus 7%. So I guess that's 1, 1, 1. All the ones if you do bingo. So your final score is out of 111%, and the grading scheme is out of 100%. So these are standard grading schemes for 100%. So you get a slight boost, but it's a challenging class. So don't think that it's a gut. I don't think it is a gut. So we'll see. So that's kind of the prosecution of it. As I say, we can look at Canvas to see where all these individual components are. And so I'm in student view right now, so this is probably what you see. Under assignments, okay, right at the bottom here, download midterm and final exams and solutions 2009 to present. And so there are two action items I think you should come out of this class with today. One is to download the weekly homework problems, 7th edition of Munson. And you can download them onto your computer, obviously, and they will look something like this. And so they're from the 7th edition, chapter 1. You'll have all the material you need to do these at the end of this week. They'll be due a week Thursday at midnight, Thursday. Before you go out on Thursday, Make sure that your assignments are done because it's a sharp cutoff, and you're never very good at doing it coming back at 11:30 on Thursday and trying to get this stuff done. So it's a pretty hard deadline. It's hard. It's a hard deadline. And so obviously if there's extenuating circumstances, maybe, but then the question for extenuating circumstances is why didn't you do it on Monday before this happened to you and get it out of the way? Because you have all the material as of the previous Friday. So the assignments are there. So download that today. Do not do the questions in the 8th or 9th edition of Munson if you go ahead and get that. The other thing you should do today is to download and start looking at the midterms and finals. It's a zip file, so I won't wonder how quickly it will download. Let me do that. It'll go into my downloads folder. It's still thinking. Maybe too many of you are online on using up the bandwidth. But it has the prior exams from the last, 13 years, I think, 2009 to present. There it is. And not only does it have the exams, it also has the solutions to those exams. And so it'll open up here. You'll see exactly what it is. Perhaps you're downloading it now as we speak. So the 4 exams, 3 midterms, and does this get bigger? No, it doesn't. And so in each of these, you'll see them. If you can see, you've got good eyes. So you'll see the exams from last year. I'll show you the solution. The solution is just the same as the individual PDFs, so you can see exactly what's going on. Do this. So they all take this form. This would have been Monday, first exam last year. You can see the questions with the working, with the answers. And the answers are submitted not on the paper sheet, but on Canvas. So Monday, 5 weeks from now, or whenever it is, you can come to class if you want, but at 7:55, Canvas will open the assignment. It will serve you not the answers, but the questions, and you will deliver the answers online onto Canvas. It'll close at 8:31, and you'll get your instant score straight away. There's a plus or minus 10% bound on the numerical answers, so they're not multiple choice. So that's a pretty fair bound. It's worked out fine. This class used to be, we had in-person exams, 3 midterms on a Wednesday evening. I hate to talk about the assessments all the time. It sounds so draconian. But we used to have 2-hour exams on Wednesdays in a lecture theater set out. You could stay until midnight. Some people did stay the full 4 hours, and they were the same 3 questions, but they were more involved. And so the deal for doing it online and doing it in a short period of time, 30 minutes and holding you to that, is that they're slightly more straightforward exam questions than they would be if they're on a broader, more wide-ranging exam where you get extra credit for at least putting down the equation you could have used or parts of the equation and getting some credit for that. And so that's kind of just a reality of the class. So we'll do it this way for sure. The trade-off is that these are easier questions, but you don't get extra credit. And the other one would be extra credit, but really much more difficult questions. So certainly when we did this the first time, this was brought about by necessity for COVID 2 years ago. So this would have been a COVID one as well. It was a necessity because we just had to be off campus in that year. So it was spawned by that. And so that is exactly what that looks like. If I get out of this. The other thing that is on Canvas is, so you can download them. So the other thing is that as you look through these tests, you will see that in the last 2 years, they look slightly different. Perhaps you can sense that the questions are less demanding. They should be because of what I just said about the extra credit. Before that, they were all in-class exams, and so they're more complex. So if you are looking, I would say that the one arbiter of how well you do in this class is how well you're going to do in the midterms. Because 70% of the grade, nominally, right? 60% midterms, 10% finals is based on that. So I always admonish students to, by the time you've come here next time, to have downloaded it, if you haven't already today, while you're online, and to have started looking at it. Because understanding that stuff, even though you won't have had it in class yet, because we haven't talked about it, is really the background that you need to do well. So I think that's the main arbiter of how well people do in this class. So going back to the assignments, the other thing in terms of the exam, so we've talked about the importance of this, is there's also a practice exam. And it's a short practice exam. I think there's even a solution for it there. So you'll see this online. The first time we did this 2 years ago, I felt obliged to give a practice exam so that people knew exactly how to do this. And so this is exactly the practice exam with the answers boxed. And if you go to the actual delivery of the exam, take the quiz, and you can do this as many times as you want. Some of them might be multiple choice, some of them might be a real answer. I think it was 2.5, but I can't remember. 7, I don't know what these are. I'm just making it up, of course. And you get, well, I didn't do very well. The practice exam will tell you whether you're doing it correctly or not, so you can get some feel for it. The real exam, we used to give people 2 attempts, but people started gaming that system and using it well and running out of time. So there's only 1 attempt. So you've got to come up with your answers. You've got to submit them. If you run out of time and you don't get it in before it closes, fine. Email it straight away. And that's not a problem. Comes in the next minute, 5 minutes, 10 minutes. The internet goes down. We've heard all the real and spurious problems that people have had, but we can accommodate people, but that's the way that the tests are done. So what else? So the tests are done that way. You can come to class and do it. You can do it in the comfort of your own home. Honor code is you should not have any kind of social or real interaction with people while you're doing it, according to the Penn State honor code, etc. The homework assignments, again, we looked at the fact that you should download these. This one will be live already. They're each 10 questions worth 100 points. Some of them are multiple choice. The first one is talking about dimensions of units that you have and being able to convert units between Fahrenheit and centigrade and PSI and SI units, English units, so-called English units and SI. I guess this one has 11. Oh, I'm surprised it has that. Don't know why it has. Oh, that's because it's the question number. 10 total questions, but that's the question on the Munson book. And see how I do. You get 3 attempts. It'll tell you which. Oh, that's pretty good. Oh, yeah. So 3. If there are 5 answers, then I should get 20%, right? That should be what I get. I'm not sure what I got. I got 10%. I'm even underperforming for you. I can't believe it. So even by guessing them, right? If there are 5 questions, 5 answers for each question, by guessing it, on average, you should get 20 out of 100. So I underperformed for that. So for these, I'm sure there's answers out there. But these, you're shortchanging yourself if you do that, because this is where you can learn some of the concepts we had in class. You get 3 attempts. It'll tell you which ones are right and which ones are wrong, but it won't tell you the answers to the wrong ones. So you get 3 attempts. I used to do 4 attempts for the first one just while you're getting into it, but then I kept on getting emails. Why do we get 4 attempts for this? We didn't get 4 attempts for this one. So they're all 3 attempts. So you'll see, and you must be experts at using Canvas at this stage in your careers. What else do I have there? So you'll get a cheery announcement from me. So the assignments will close at midnight on Thursday night, 12 p.m. on Thursday. You'll get a cheery announcement from me on Saturday morning at 12:01 a.m., which will say what the deliverables are for the coming week. It'll be similar to this, and it'll have these kinds of things in it. Classes in class or online this week. Is there homework due? Yes, there's homework number 1, number 2, number 3. And what else are there midterms this week? No, there's a practice session be recorded on Thursday. The midterms will be the week after that. And so hopefully you'll be able to keep apprised of what's going on from the individual announcements. The assignments I mentioned, I have no idea what the discussions are. I was going to wipe that. These must be from a previous year. I never used that. Grades are all done so that the right amounts go in the grades. I will mention this, is that this always becomes an issue at the end of the class, and it might do in your other classes as well. Canvas will do the right bookkeeping for you. It will do the right calculations for you in this class because we've set it up with 15% for the homework, 15% for the group presentation, 4% extra credit for the quizzes. The final exam is 10% boosted by 10%. The midterms are 60% boosted by 10%. So it'll do the right calculation for you. So the total will be out of 110%. It has the right grading scale in it so that an A is 93.3 or more. And so it'll do this. But this button here is important because the grade calculation that Canvas does is if you haven't done an assignment, it doesn't take that amount for the assignment in the denominator when it's calculating your grade. So for instance, if you've done none of the assignments throughout the whole semester, the 15% that you haven't got won't show up in Canvas until you click this button, and it tells you after the class is closed on the Friday before finals that you got 0 for that assignment because you didn't produce anything. It's not just that you haven't attempted it yet, it's that you got 0 for it. And so I would, in this class and your others, be aware of what this button does. The button should be clicked because it gives you the true grade. And so without fail, when finals come by, I got an 88.2, but I only got a B minus. No, you didn't. You got an 82% because you didn't click the button. So if you haven't seen that in your other classes, then be aware of it here. I don't know what you guys see when you search for people. Do you see all of the people? Maybe you do. I think you do. So I'm in as a student. I get other privileges, I guess, but I'm seeing this as a student, so I guess we do see all the people. Pages must be the files. I made the mistake in the first year of COVID to put the tests online, and they're actually available to the students to download. And of course, when you see exam 1, 303, 1.1, then people realize that it might be the actual exam. There wasn't the solution, but people did very well on that exam, so we cancelled it and just went on. And I was the wiser for knowing how to put things hidden online. So that's a mistake I won't make again. Syllabus we've seen. So I guess this is the important one, right? It has a syllabus and the course resources page. I have no idea what the big blue button is. Do you know what the big blue button is? No, okay. I realize I'm doing all the talking. Any questions? I can talk all day. And do. Sorry. No? Okay. Well, I'll keep on going. I don't use chat. So I think that's probably all the components. So today, just to reiterate, I'm not finished talking yet. 2 things. Download the 7th edition questions, download the midterms and finals, and start browsing the finals to gauge your familiarity. Lots of you have had components of this class in your past. Pressure, it basically draws on statics and dynamics. So you'll have things like pressures, stresses, Newton's second law, Bernoulli's equation, which comes out of Newton's second law. Some of you already seen those, and so you'll get to see those as we go through this. All right, what else? Should we go back to the syllabus? So we've talked about the grading policy in terms of all the individual things. There's a bit of narrative. The narrative really just says exactly what I've said in terms of those, so I don't know that we want to do that. So I'm trying to think what we've done here. People, we've talked about. Modality, in class, according to this schedule. This schedule may change. You see it's August the 19th at the bottom. So it may change if for any reasons. I can't make it to class for some reasons, but this is the modality. You're welcome to come to class. You're welcome to not come to class. Obviously, when it's asynchronous and online, coming to class won't yield you me, but it will be an empty room, which won't be otherwise used. Only for the classes which coexist with our midterms will there be an extra credit component. If for some other reason we get online asynchronous classes, those will also be extra credit. So instead of being 4%, it will be 5% or 6% or whatever. The breakdown of these individual horizontal lines kind of define the material before this, which will be present on these midterms. And so the midterms have been pushed a week further forward this year because the last 2 years they were on the previous week. And so obviously if they're on the previous week, there were no classes, so the videos recorded from those are at least 2 or 3 years old. So that's why I'm switching around. And so likewise for the second set of midterms, the cutoff date or cutoff material is this stuff going backwards, and you see as it goes through. The final is never comprehensive. It'll only really include the stuff since the last previous one. So the external flows, wind turbines, forces on airfoils, how planes fly, and open channel flows. Flows in ditches, rivers, streams, hydraulic jumps, etc. So those are the topical areas and the conduct, I guess, of modality. The material, well, it's a pretty comprehensive class. We mentioned the text and whether you want to get that or not. The one that's in the library is a black and white copy that has a couple of chapters removed out of Munson, which we don't use. Those 2 chapters are compressible flows, like air going into gas turbines, and turbo machinery, which we don't really do in this class. And so other than that, it's the same text as you'd buy. If you get it and rent it online, I think it's about $50 instead of being maybe 120 for the used copies in the bookstore. The syllabus is kind of outlined here in terms of what we talk about. Maybe it's worthwhile quickly talking about it. This is today. Orientation today, we'll talk about fluid properties, mass, density, viscosity, surface tension, the things that you need to understand the behavior, phase behavior, ideal gas law. Second week, we'll talk about fluid statics and how that defines fluid pressures at a point. We'll use that material then to talk about if we integrate those fluid pressures, we can look at pressures might be acting on a structure, like on the back of a dam, where you have a fluid pressure acting at a particular depth and a different pressure acting higher up and an even different pressure acting higher up, just like in a swimming pool, how you integrate those to find out what the force is that's acting on that dam. And then we'll talk about fluid dynamics. So fluid dynamics is Newton's second law from your dynamics course, I guess EMEC, is it 211? Dynamics. And F equals ma, which is the same as the 3 components of Bernoulli equation. We'll use that. And then we'll spend 3 weeks talking about conservation equations. So conservation equations are in 3 forms as well. Conservation of mass, the amount of marbles that go in the bucket are the same as the amount of marbles that come out of the bucket. Conservation of energy. So F equals ma is conservation of energy. The amount of energy that goes into a control volume is equal to the same amount that goes out plus the accumulation of energy. And the energy equation written from the point of view, so this is, I guess conservation of energy from the term of momentum energy. And this is a general one in terms of thermodynamic energy, in which case the amount of thermodynamic energy, such as in 301, that goes into a control volume, has to obey the same laws. Energy in equals energy out. What doesn't go out gets accumulated. If more goes out than goes in, then you get depletion in the control volume. So it's very, very straightforward. And so this idea of using Reynolds transport theorem is just a way of doing the conservation equation so that instead of going into a bucket, we could look at it going into a differential cube, dx, dy, dz, a little tiny cube. Or we could look at a whole structure like a car where the energy that goes in, gasoline in, combustion, energy out, heat out of the exhaust, and the amount of energy that gets transmitted to the wheels. We won't do that. That's too complicated for us. But that's the basic idea, is that you don't have to have a little differential volume. You could have a contour that goes around a structure, such as a car, and you can do everything that you can do in differential analysis. Doesn't matter. Too complicated for today. Some of the assignments, which I apologize for, are in English units or imperial units and SI units. The exams will be exclusively, and the course is exclusively in SI units. So we only use that. It's the only logical set of units. The US is the only country in the world, I think, that doesn't use it. Don't know why, but it doesn't in terms. But we'll use it in this class. It's much more logical. We will, after we've talked about conservation laws, we'll then get into the applications. So the applications, the first one is a thing called dimensional analysis. One of the first tasks you'll do, your first week of homeworks, you saw that the questions were MLT, mass, length, time. For us, those will be kilograms, meters, and seconds. And so when you get a quantity such as mass, which is kilograms per cubic meters, that is in mass per length to the power 3. So those are the units in terms of the fundamental components. So when you're designing experiments, you can actually use this very nifty thing called dimensional analysis to tell you what your answer should be in terms of its dimensions at least, so that you can do the minimum number of experiments to be able to explore that system. It's a very, very clever technique. And so we'll talk about doing that. But you'll get exposure to that in your first assignment by defining some of these quantities like velocity. What are the units of velocity? Well, length over time, L t minus 1. So the applications then are things that you might want to use in your professional lives. I don't think it's very interesting compared to how the weather works, or how, if you came in early, how volcanoes cause tsunami, but certainly flow in well bores to get hydraulically get gas out of the subsurface, hydraulically fracture reservoirs, get contaminants out of contaminated reservoirs, bring up geothermal fluids from depth, and mining engineers looking at airflow around the tunnels within a mine. All are flow of a fluid, sometimes liquid, sometimes gas, in a structure, a long structure compared to its cross-section. So we'll talk about viscous flow in pipes of all different kinds. We'll talk about external flows. So external flows would be the flow that allows you to fly from Pittsburgh to San Francisco in an airplane, how an airfoil works and provides lift, or how a wind turbine blade works, or how a sail in an America's Cup boat works. And then the final topic that we'll deal with, perhaps less relevant to most of the majors that are represented here, is open channel flows. So flow in a ditch, flow in a canal. I guess the topical news now, if you look at the news, I don't know if young people look at news, we get it on different social media. You'll see that the Rhine in Germany is drying up. They're having to barge it with a fifth of their normal loads because there isn't enough draft in the Rhine because of the droughts going on in Europe. And so a big issue in that, in terms of linkages between climate system, which is fluid mechanics system, rainfall, surface water flows, etc. So those are the components. The breaks for these, I used to have dates on these. These are the individual midterms, which don't, I guess they do go with these breaks, but these breaks are perhaps more easily seen on this. What else? Well, we've got 5 minutes to go. The other thing that perhaps is useful to you to realize is, what else? Well, we'll do presentations. I'll talk about the presentation sometime. The other thing that perhaps is useful to realize is that on the course resources page, which should still be up here. I guess we don't have the course resources page. Is that for each of these, so for each of the midterms, there are not only review notes, which are kind of a concatenation, a reduction in the material that you need to know, but there is also for each year a review video. And that, like everything else, will be given to you a week before, in the Thursday at least, before the week on which the test is. And you'll see it's not playing, but you can see it right here. It'll play for probably about 20 minutes, and it will cut you a bit of a break. It cuts you a bit of a break, and it tells you when the test is, tells you that you have to come to all 3 tests. Don't do what someone did last year, said, I thought I could pick whether I came Monday, Wednesday, or Friday just for these tests. We have to come to all of them? And this was halfway through the semester. It wasn't very helpful. So you do have to come to all 3 offerings for each test. And some idea of what the materials are for each of those questions. Questions 1, questions 2, and questions 3. And then, just to show you how generous I am, some discussion of what the key points are for each of those topical areas, to walk through them, to summarize it. And so you have the previous tests from last year and the year before, and back almost to infinity, back almost to the years you were born, right? It's half of your life is there. So you have those tests, and you have the solutions, so you can certainly check against these review videos, which have been running for many, many years. They've been recorded. Sometimes they used to be given in person, but in more recent years they've been running for almost a decade as well. You can see exactly what we talked about. And you can see whether I'm spinning you a yarn or whether the things that I cover quite succinctly and quickly and concisely in the review session are the things that end up on the test. And hopefully it will confirm it, that I'm not giving you a complete different slate of materials to talk about and leading you down the garden path. And that's probably it. I don't think that's probably it. So I think it can be a great class, but I'm biased, of course. You know what the modality is. If you think my voice is screeching on you, can't stand it, you can go back and you can watch the YouTube videos, as this class today will be put online on the course resources page. You can do it at double speed. I don't think YouTube does it faster than double speed, but certainly you can download it and you can do it at 30 speed if you just want to see what's going on. And so there's all kinds of different ways that you can do this class. Any questions?
Actually, I have a question.
Yes?
So, you just mentioned that there might be 3 tests every...
No. Every test, well, I probably shouldn't tell you this, but every test that you'll get on a Monday will be the same test for everybody, but there'll be a different test on the Monday for everybody, and there'll be a different test on the Wednesday, the same test for everyone on the Wednesday. A same different test. There'll be one unique test on the Monday that everyone will take, identical. Please don't talk with each other while you're doing it to find that out. And there'll be a different one on the Wednesday and on the Friday. The hardest part for me in this class, actually I'm probably working harder than you, is that I need to come up with new tests each time because you get the answers to the previous tests. So obviously, if it's kind of open book when you take the test at home, there's no point in me giving you a prior test because you have the solution already. And so I'm working pretty hard here. So, answer? Any other questions before we take off? Yes?
Is the final exam also taken online?
Yeah, it's exactly the same format, just in the final week of classes, not in exam week. Yep. My office is 231 Hostler. It's on the syllabus. My door is always open. I have an open door policy. But you should, if you want answers to question 4.2.7 and you can't work out while your decimal point is one place off, you're probably better off talking to the TA to get that answer. I'd love to talk to all of you to find out where you're from, to see what you're up to, what your career goals are, just to have a chat. I prefer to use my time with you in that quality mode rather than do what typically the TAs would do. So my answers to those kinds of questions, if you come, would be, well, what would you do to if John said, what equation would you use for that? Have you worked that through? So anyway, so go and see the TAs. So there are lots of resources in this class. Prior material, there's 10 years of material. You can probably find the answer to the question you have somewhere online or on someone else's website. You can certainly find it for the TA hours. The TA will have 10 hours a week. There'll be 111 Hustler. He'll set them up once he's on campus and finds out what his schedule is. I don't know if he'll do Zoom as well, so you can Zoom in rather than be there. We'll see as it goes on. So please do come and visit me, especially in the afternoons. My door's probably open all the time. Afternoons are probably better. Mornings is a good time to get stuff done sometimes. Any other questions? Yeah.
So where are we supposed to download the homework from? I looked under the assignments. I thought that's where you got it, but there was only the text.
It was right at the bottom of the assignments. I thought. Right, so I'm in student view, so this is what you should see. Assignments, I think it's in the box beyond the bottom of them. Right here. It's undated assignments. I don't know why it's in there. So this is the homework assignments here. So it's on the same as the assignments, just at the bottom. Got it? Yeah.
I'll show you after.
All right. Fine. If you're an eager, I did tell you should download it before next time, but I won't hold you to that. So yeah, download those two things. It's assignments, if you don't have them by next time, we can sort it out exactly where they are. They should be showing up there, and they should be available to you. Download the tests and start looking through them. I really do believe they're the greatest arbiter of how well you do in this class. It's having some, because 70% of the grade is done in that format. Okay, so great, good to see you all. I love it when semester gets going. See all these happy spaces. Probably not even raining, but maybe it is. Who knows? Thanks very much.